I'm working on a CNC machine to help me make crease patterns more easily, so I can work on complicated origami folds, because origami is a lot of fun. This is what I've built already. This is a little materials testing jig for origami. So I've just decided to use a bookbinding paper, an end paper for bookbinding to fold out. It's nice and thick, but it also holds a crease, or it's fairly heavy weight, I guess is the paper term, but it holds a crease well. And so this is kind of a movable bar, and this is a kind of base, and the paper slides along here with a little creasing tool, which is not modeled because I just kind of turned it out of scrap. I should say lathed, but lathed is not a verb. Here's the turned bit. The paper runs along here, and the goal I'm trying to figure out right now actually is how much force does it take to crease the paper, and I want this to be a roller feed tool, so like kind of like a vinyl cutter. So how much force does it take to pull the paper? Start out making a little layout of the Irwin. Make this a layout just so I can kind of drive everything from there. I actually have a clamp on me, so I'm going to have to kind of guess the dimensions and figure things out from there, basically. That's kind of where I'm at. I think the best way to do this is a side view. I'm not sure it really matters here, but yeah. Nah, a front view probably, just so I can get the sliding geometry right. I don't really care so much about the actual clamp body. I just need a little dummy head. Some nice mirror line to start out. Do this for center it. I remember seeing there was a decent little video about accessories, which actually gave a decent shot of what these looked like, kind of sliding on and off. It looks like that whole system just pops out, so I could, yeah. So I think I don't need it to pivot, because I'm already going to have some compliance in my TPU part, so it's just literally an edge. Can I get in the ballpark? What are the dimensions they list on these things? These are the pads it looked like we were trying to replace. You have a little thing here, but there's not really only a brochure I just looked at earlier, which isn't super useful. So this is 1.8 by 1.5. So I'd bet they don't have a view of the back. That would have been nice. I'll bet did this have a view of the back? 3.5 by 1.38 by 1.3. Also no view of the back. Looks like this is the kind of the width that they all seem to float around. And it looks like that protrudes over kind of quite a bit. So I'm gonna ballpark that to be like, this can be 0.5. It'll be 0.75. There's kind of our base body I'm gonna be working from. So now I'm gonna spec an FSR of some kind. I think SparkFun had some decent load cells. I was looking at one of those compression load cell. Nope, not quite. Compression load cell, just because I don't want to have to set up a big bridge, and that doesn't work so well. They make some nice ones, but those are kind of expensive. I was looking more at something like this, which is just kind of something you'd find in a scale. There are also some generic ones on Amazon. Now we can bring that in here. There's the there's the load cell clamp thing. The part we're about to design is actually going to clamp on the end of the paper and it's going to measure the force required to pull the paper or feed the paper through this. After finishing the mechanical parts of my testing jig, I had to work on electronics and programming. how each of these strain gauges work is that there's 3 lines. There's 3 lines going in, and they both act as resistors, right? So here's a resistor, and here's a resistor, and they're both kind of defaultly around 80 ohms. They're kind of in their regular configuration. No. But this one down here is actually a variable resistor that varies as you put pressure on the strain gauge. You've kind of got like a big bonded wire, big wire thing that as you lengthen the wire, you increase resistance and lower it, but it's only changing a really tiny bit. So we need to have an amplifier to measure that, which is what I just soldered everything to. This is an amplifier. We also have to measure a change in resistance as opposed to voltage, so we have to have a Wheatstone bridge. And since I have 2 sensors, I have to have a half bridge. I require measuring the pressure down. I need to measure on the paper and how much force it takes to pull the paper. These are the kind of 2 things that are tunable in my eventual little CNC machine design for pre-creasing origami crease patterns. And so I thought I needed 2 amplifiers, and I kind of got the HX711 for free because it just kind of came in the box with the generic little strain gauges for a bathroom scale, which I just kind of bought from Amazon. The other ones I bought from Sparkphone. And I thought I was going to need both of them. I thought I was going to need the NAU for measuring my pull sensor, and the HX711 for measuring force down. But it turns out HX711 has 2 channels, and you see 2 electrical input channels, and one of them I believe is much lower. Actually, looking at this now, it's just got a multiplexer, and it just swaps them between its ADC. Somewhere I'd read that the second channel was not particularly useful, but it should be exactly the same resolution, unless this mux does something weird. Thanks for having the block diagram. So I'm getting to program that, and I'll It took me a while to get all the code working, but eventually I could read from both channels, and I began testing. Even found an interesting new use for Kafka here. Here you can see some of my results. The force down on the paper, the creasing pressure, is in yellow, and the force to pull the paper is in red. In fact, in one of these you can see the paper ripping, which takes about 6 kilograms of force. Using these, I can move on and begin speccing the torque required out of motors, for example, on my machine, on my CNC tool, or the force that the solenoids to press the paper down need to be able to apply. Anyways, thanks for watching. Hopefully that gave you a sense of what working on a project like this entails. Currently, I'm working on machine design based on this testing data, and I'm going to start building my final tool next week, but I thought it would be more interesting to see more of a finished project, even if it's smaller. Anyway, thanks again. Bye.